Hi everyone. Thanks for watching this video. I've been, since lockdown started, indulging myself in some hard Sudoku puzzles, and I thought it might be fun if I just recorded one, and if anyone's interested you can play along and watch the solve. So my Sudoku here is called a cursed Sudoku. First of all, for those of you that aren't familiar, a Sudoku is a number puzzle in which the numbers 1 through 9 must appear in every row, every column, and every box without repeating. It's that simple. And in this case, we're given, I think, 10 or 12 given digits to begin with. And the rule set on this particular Sudoku, this is called a cursed Sudoku, the purple boxes are restricted. They may not contain the same digit as their row, column, or box. So this one, for instance, could not contain a 1 because it's in row 1. It's also in box 1. It can't contain a 3 because it's in column 3. It can't contain a 4 or an 8 because they're already in the box, or a 4 and a 9 because they're already in the row. And that's the rule set. It's that simple. So what we do then is go off of restrictions to force numbers into place. The control panel here on the right on this software, the normal setting is if you want to put a number in. If I wanted to put a 6 here, I could do that. I could either click the number or I could use my computer keyboard. If I were to put, say, an incorrect number in there, this would happen, and it would say, oops, this is red, this doesn't belong here. So I'm going to erase that now. I can use the delete key on my keyboard also, or click. The second option here is the corner button. I use that to mark the corners of cells that are forced into something. For instance, there's a 4 here and a 4 here, so I know a 4 has to go here. So I might go there and highlight those cells and put a corner 4 in there. That reminds me that 4 can go nowhere else in this row and nowhere else in this box. So if I have to look at it from another angle and think a 4 could go here, I'd say, oops, no it can't, because 4 must go here. And then I'm going to let me erase those. And the other one is a center mark, in which case, say suppose these 3 cells, by some way or another, I've narrowed it down to the only possibilities for them could be 7, 6, and 5. So I would mark them thusly, reminding me that 7, 6, and 5 couldn't be anywhere down here or anywhere up in here, and these are the only possibilities for that cell, for those 3 cells. And in the highlighter, down at the bottom, will give you a chance to use color coding if you'd like. I won't use it on this puzzle because the color coding is not necessary, but there's certain variations that it comes in handy. If, for instance, you figure out that this cell and this cell, somewhere or another, have to be the same digit, I could highlight them and mark them in any particular color, and then whichever one I figure out first, I can immediately fill it in the other one. Of course, I won't be doing that with this particular cell, or with this particular puzzle, rather. So let me erase these. Let's see, maybe I can. There we go. So now, with all that said, I think I'm going to take a stab at this puzzle. You're welcome to stick around and watch. It's nothing more than an exercise in logic, but I figure I might as well exercise my brain during quarantine and lockdown, because I'm not doing that well exercising my body. So here we go. The first thing I'm drawn to in this puzzle, there are lots of restrictions, right? Lots of purple. This column is interesting. This column is interesting. But I think I want to start in box 5, mainly because there are 4 givens and 4 restrictions. So let's take a look at that for a moment. The restrictions here are in row 5. The restrictions here are in column 5. And they're all in box 5. And there is no 5 in the box. So therefore, the only place 5 can go is right in the middle. It can't go here in the purple squares because of the row. It can't go here in the purple squares because of the column. And in fact, it can't go in any of the 4 purple squares because it's in the box. So now let's take a look at these restricted squares. And I'm going to center mark these. This can't be a 1, it's in the box. It can be a 2. It can't be a 3, or a 4, or a 5, or a 6, or a 7 or an 8, but it can be a 9. Those are the only two options for that box. And looking down here, it can't be a 1. It can be a 2, not a 3, not a 4, not a 5, not a 6 because it's in row 6 and it's purple, not a 7, not an 8. That can also be a 9. Now the situation I'm in is that I have these two cells that can only be 2 and 9. Well, that rules out 2 and 9 from up here, and from down here, and from anywhere else in the box. So, given that information about the box, what can I put in these two purple squares? Well, the only two numbers that are left to fill in the box are 4 and 6. Well, this is in column 4, so a 4 can't go there. So, by process of elimination, it must be a 6. The same thing here, this is in column 6, so that must be the 4. Now I have a little more information in the center. So let's expand this a little more, and let's go back to this column 6 with all this purple in it, all this restriction. Where can the number 6 go in the column 6? Well, it can't go in the purples. Can't go here. Can't go in the purples. There's only one place for the number 6 to go, right there. And now let's look at row 9. We can apply the same logic there. Where does 9 go in row 9? Well, it can't go here because it's in the box. Can't go here because this is purple and occupied, and this is purple. So 9 must go there. Now we know that locks 9 into here. Right? So I'm going to put a corner 9 right here and another one right here. Why didn't I put one in the middle? Well, because 9 can't be in that column 5 because of these two squares. It's got to be in one of these two, so it can't be here. So 9 is now restricted to here. Let's look now at, how about we look at row 2? Well, where does 2 go in row 2? It can't go here, can't go here, it can't go here for the same reason that 9 can't go here. That's purple, those are purple, so the only place left for a 2 is right there. Now, let's see. Where shall we look next? Let's look at row 4. The same logic applies there. Purple, there's a 4 here. Purple, these are all spoken for. Purple and spoken for, so 4 is forced into that square. So let's go back up here in the beginning, like I used 4s as an example. We have 1 in row 3, we have 1 in row 1, so there has to be 1 here for regular Sudoku rules. I will corner mark those with a 4. And now let's look at the bottom. We have a 4 here and a 4 here. Well, 1 must go down here somewhere. Guess what? That's column 4. Can't go here, can't go in the purple. So we have another digit entered into the grid. Now let's take a look at 4s. Let's keep working with 4s. We have here, here, so that means here. And the middle one is not valid because there's a 4 in column 2 already. So I think I'm going to corner mark these. 4 here and 4 here. Okay, that was pretty interesting. 4s can't go here or here, but there's no real more information here. It can absolutely go in the other 4 squares down here because they're not in row, column, or box 4. Okay, where shall we look next? Let's look at column 6 again because all of the squares that are left are restricted. So what are we missing from the row? 2, 5, 7, 8, and 9 have to go into these 5 purple squares. 2, 5, 7, 8, and 9. So 5 is in this box, so we know the 5 has to go up here. 2, 7, 8, and 9. Well, let's see. Where can 9 go? 2, 7. Let's just put 2, 7, 8, and 9 in here, and we'll center mark it, and we'll start eliminating. None of those can be 8 because this is box 8. So I'm going to eliminate the 8. That means actually the 8 must go up here now, right? So that would leave 5 and 8 together in a pair. So I'll erase those corner 5s and I'll put 5 and 8 in a pair right there. Well, looky here, Mr. 8 is already in row 2. That forces a 5 there and forces an 8 there. Now let's come down here. We have a 9 here and a 9 here, which forces our 9 here. And this becomes a 2-7 pair. Now that row is nearly complete, except for the 2, 7, but we know that's where they belong. Okay, now let's take a look at column 4 again. We already have a 4 placed in it. What's missing from this column? We've used 4, 5, 6, 7, 8, so that leaves 1, 2, 3, and 9. Okay, so let's look at the top box. A 1 can't go here because it's in row 1. A 2 can't go here because it's in box 2. A 3 can go here, but a 9 can't because it's over there. So indeed, that is a 3, leaving us with 1, 2, and 9. There's a 2 here, but the 1 and the 9 can both go there. I think all 3 of them can technically go there. The 9 cannot go here because there's 1 in the box, so that has to be either 1 or 2. And it actually can't be a 2 now because we know in this box the 2 must be in one of these 2 squares. So that forces the 1 there, which forces the 9 there. The only thing left in the column now is 2, which is now forced there. Now let's look at what's missing in this box. 3, 6, and 8 still need to be placed in the box, so I'll center mark those as the only options. This can't be an 8 because it's in box 8 and it's purple. The other options are still valid because they're in white squares. What does that leave in this box? It leaves a 1 and a 7, doesn't it? So we'll put 1 and 7 there as a pair. We cannot disambiguate which is which just yet. But we'll come back to that. It'll be ready for us when we find something else in another row or another box that disambiguates it. Okay, let's continue now with 9. So we have 1 here and 1 here, so 1 needs to go here. Well, it can't go in column 1 because there's already a 9, so it must go here. That puts a 9 somewhere in here. We can't restrict that at all because there's no corresponding information coming from the side or the purples or the rows or the columns or the boxes. So I'll corner mark those 9s. Let's look at the 9s over here. You have 1 here and you have 1 here, so that means it has to go in one of these 2 squares. So let's corner mark a 9 there. Let's take a look at row 7 now. A lot of purple, and everything is spoken for except this one lonely little square, which must be a 7. It's the only place you could put a 7 in row 7 with all these restrictions. So now we have a 7 in row 7. Look at column 8 now. There's only one place for an 8, right there. Now that eliminates the 8 from being a possibility here because it's in the row, so we'll eliminate that, leaving the only place for the number 8 in box 8 to be right here. So we'll place an 8 there. Now, that leaves a 3-6 pair, a 2-7 pair, a 2-9 pair, and a 1-7 pair, all of which are waiting for a little more information so we can disambiguate them. Where to next? 6, 6, these must be 6, but there's no restriction, so I'll mark those. Let's see here. Let's look at column 7 now. Where does 7 go? It can't go here because it's in the box. It can't go here because it's in the row. All of these are purple. It must be in one of these 2 positions. So I'm going to corner mark a 7 here and here. Where to now? Let's see. What can we restrict next? Let's look at this box over here and see if we can. There's a lot of information from a lot of directions going into box 3. So let's just see what we can put in here. Let's center mark. We know this can't be a 1 because it's in row 1. It can't be a 2 because there's 2 in the box. 3 and 4 are in the row. It could be 5. It can't be 6. It could be 7 and 8. It can't be 8 actually. It can only be 5 or 7. That's very restricted. I like that. So let's look here now. It can be a 1, but not a 2. Be a 3 and a 4, not a 5. Can be a 6, but not a 7, 8, or 9 because they're in the column. That's not quite as restricted as I was hoping for, but we'll go with it. Over here, 1, 3, 4, 7, and 8. No, not 8. I'm sorry, 8 is in the row. Okay, it could be worse. I've done some of these things where I've had 6 digits in a box, 7 digits sometimes, and we just keep eliminating them. So let's see, what else can we do here now? Well, let's go ahead and look at these. I'm just going to fill in what's missing from the row and then delete what doesn't belong. So that would be 1, 3, 5, 7, and 8. 7 and 8 can't go here because they're down here. My goodness. Okay, this is in row 3, so 3 can't be in either of those. So no, we're pretty restricted here now. That's helpful. 7 can't be in this box because 7 is restricted over here. The same goes for that box. A little more restriction. Okay, let's look and see now about what can we restrict next? Let's look at the bottom box here, box 9. Well, that's not all that restricted, to be honest. Oh, I see. 7 must be here. 7 is here, so 7 must be here. It must be in a pair with the 9s, and there's a 7 showing across here, so 7 is forced into there, forcing 9 into there. That forces 5 up here, and 1 here. And that removes 1 from all of those because they're in the box. It removes 5 here and forces an 8. That 1 sees this pair and makes that a 7, which makes this a 1. Okay. All right, that's progress. What does that leave us down here in the row now? 1, 3, 4, and 1, 2, 3, and 4 is left over. So I'm going to center mark those. I'll eliminate the 1 because it's in the row. The 4 is in that row. Everything else appears to be valid. All right, let's look in this box here. I'm just going to fill in everything that's not in the box and then subtract. 1, 2, 3, 5, and 8. So we know 1 can't be in this column. We know 8 can't be in that column. Here, actually we know 5 can't be here because it's in the row. 3 can't be there for the same reason. 5, 2, 3, 2, 3, 5. Okay, now this is an interesting thing, right? You have 2, 3, and 5 in these 3 boxes. Those are the only possibilities, which means they must be in those boxes, which means they can't be in this. So 2, 3, and 5 can be eliminated from there. And 3 can come out of here for the same reason. So if this is all 2, 3, 5, everything else is filled in, and this is 4, 6, this must also be 4, 6 to fill out the column. We have a 1, 8 pair here now. See if that helps us figure out what's in row 7. Not all that much, to be honest. Doesn't help that much. Okay, let's see what else we have now. Let's look over here in row 2. There's a 1, a 2, a 5, 8, and a 9. So that leaves 3, 4, 6, and 7. We know 4 can't be in either of these. It's in the box. This is in column 3. Now we have not quite enough information. Not quite enough. Let's go back and look at box 3 now. What's missing from here? We have 1, 2, 5, 8, 9, which makes 3, 4, 6, and 7 left over. So let's fill those in and then subtract what doesn't belong. 3 and 4 are in the top row. 4 is there, and so is 6, and so is 7. 4, 6, and 7 are here, so that forces the 3 there, which forces the 4 here, and the 6 there, and the 7 there. And that 6 forces the 7 over here, and the only place left for the 3 in the row is there. That's satisfying. Now we have one digit remaining in this row, which must be 1, 2, 3, 4, 5, I believe. Now we have 3 digits left in the top row, or in the first box, depending on how you look at it. Let's center mark those. 1, 2, and 6. This is purple, so it can't be 1 because it's in row 1. Everything else, I believe, is still a valid possibility. Now let's look at column 7 again. We only have 2 empty squares here. What will fill those in? 1 and 8 will take up these 2 in one order or another. So that leaves 5 and 6. That's correct. That leaves 5 and 6 for these 2 cells, which eliminates the 6 from this cell. It can also be eliminated by this 6. Makes it a 4. That takes 4 out of there and there. And we have a 1, 2, 3 triple, which means those will be in there in one way or another. 5, 6 pair. We got some pairs. We have another triple up here. Triple across here. And I think we're making some pretty good progress here. And let's take a look now at row 7 in these restricted cages, restricted cells, I should say. What's left in the row? 2, 3, 4, 5, and 6 need to be placed in the row. So there's a 5 in the column. There's a 3 and a 4 in that column. That's in column 3 and purple. Let's see, how else can we restrict this? Oh, this is in column 2, so that can't be a 2. Now we have a 5, 6 pair in the row, which means this can't be 5 or 6, which means this can't be 5 or 6. And now we have a 2, 3, 4 triple in the row also, waiting for a little clarification. Okay, next, why don't we look at these other 2 restricted cells here in box 9. I'm sorry, box 7. There's a 9 in it. Let's just take this one. It can't be a 1 because of the column. It can be a 2 or a 3 or a, can't be a 4 because of the row, or a 5. I think it can be a 6 or a 7. It can't be 8 or 9 because of the column. Oh, actually, it can't be a 7 because of the box. It's in box 7. This can be 1, not 2 because of the row, not 3 or 4 because of the column. I'm sorry, the column. I think it can be 5 or 6. Can't be 7 because of the box. And 8 or 9 because of the row. All right, that's fairly restricted. I don't see any exploitable patterns here with those just yet, but it will reveal itself eventually, I promise. All right, let's do some more restricting. Let's take a look at these. What will finish the row? What's missing from the row? 1, 2, 3, 8, and 9. Well, there's your answer. 9 can't go here or here, and the only place then 9 can go in the row is here. And that will take that corner mark out there, and it'll take that corner mark out there. Clean it up a little bit. And actually, it's been sitting here for probably 10 minutes. I can take this 9 here to resolve that to be a 2 and this to be a 9. That 2 resolves back to this 5, which removes this 5. And this can't be an 8 because of the column. It can't be a 1 because it's in column 1. Now we have a 2-3 pair in the row, which means this can't be 2 or 3. It must be 1 or 8, filling out the other pair. Okay, what can we look at next here? Let's go ahead and take a look at this row. What's missing from the row? 2, 3, 5, and 7. This can't be 5. This can't be 3. This can't be 3 because of the row, or 7. I'm sorry, because of the column. We have a quadruple here, but there's 1 degree of, we're 1 degree away from being able to solve those 4. Okay, and also those, and also those. All right, let's see now what we can do next. 5, 79, 1. Column 3 needs a 3, and it can't be here, so it must be here. We'll mark those. Row 9 needs an 8. You can mark those there. You should have put 5, 6. Okay. Rows, columns, and boxes. Why don't we just go ahead and fill in what's remaining in this row, and we'll attack that too. That's 1, 4, 6, and 8 in these 4 squares. Now, these aren't restricted cells, so the purple is not helping us here. There can't be an 8 here because there is actually an 8 in the column. There can't be a 4 there. And that one is not restricted at all. Not as helpful as I'd thought. So let's see what we have now. There must be something blindingly obvious that I am missing. Give me a second, I'll see if I can find it. Well, it is not immediately obvious. So sometimes I get so wrapped up in the hard parts of the puzzle that I forget to see the easy parts. So I'm just going to go back and do a little regular old Sudoku. 1, 1, 1, 1, 1, 1. 1 has to be over here somewhere, which means it has to be here, but that's already taken care of. 2 in the top. Maybe I have a digit in a restricted cell that doesn't belong there also. That's a common mistake that I tend to make when I get in a hurry. So let me slow down a little bit here and see if I can parse this out. I can't do that row. That row. Oh, almost. Oh, here it is. It's in row 8. I see it. Where can 7 go? These 3 cells are spoken for. It can go there. That's spoken for, and there is a 7 above this in column 3. So the only place a 7 can go is indeed right there. That might be the break that solves the whole thing. That makes this a 2. That eliminates 2 from here and here. Now we have a 3, 6 pair in the bottom row, which eliminates the 3 and makes that a 1. Eliminates the 1 there. let's see what we have now. If these are 3-6 pairs, this has to be 7-8. Yeah, that has to be a 7-8 pair because that's all that's left in row 9. And indeed, there's a 7 here, so that makes this the 8, and that the 7. Oop, I got that backward, didn't I? Let's try that. Our little friend, the red number, came back to tell me I messed up. So now we can start eliminating other things. Let's go up here and eliminate the 8s from here and there. Well, gee whiz, that leaves us with just a 1, doesn't it? That's a 1, which sees this 8, which sees this 1. And all of those eliminate that 1. Now we have a 4-6 pair, which eliminates this 6 and makes it an 8, which we could have done by Sudoku anyway this way. Several ways to do that. Let's see, what do we have now? 4, 5, 6. Okay, here we go. Column 3 needs a 3. The only available place for that is here. Everything else is spoken for. That forces the 6 here, and the 3 here, and the 2 here, and the 3 here, which any number of things can eliminate 3 here. We'll take that out. And the 3 here forces 6 down at the bottom. This 3 also forces that 6. The 6 forces the 4 here, which makes this a 6. This 4 makes this a 2, and that would be 4 then. This 2 makes this a 3, and that would be 7. So in the column now, we have 2 and 6 down here, so that has to be 1. There's a 6 down here, so that has to be 2. Remaining then, this must be a 6. Let's go across here. Oh, that makes this a 5. We have 5 and 6 in the box, so that's a 1. 5 sees this 6 and sees that 5. And let's see, the 2 makes this a 5, and the 5 and the 7 together make that a 2, and which makes this a 3 and a 2, and we have finished our puzzle. And the timer turns green. In about a half an hour, I took 3 or 4 minutes at the beginning to explain, and then a couple of minutes sort of messing around when I didn't realize I'd made my mistake. So there we go. We solved a hard, cursed Sudoku. And if you're interested in doing this yourself, there is a YouTube channel called Cracking the Cryptic. If you want to look them up, they're a couple of British guys that do Sudokus, and they're just fascinating. I've learned so much from them. They're big brains, and I will admit to enjoying their accents too, just because I'm an American, and it just is fascinating to me. I love accents. So hopefully this has been worth your time, and happy Sudoking. Thanks for watching. Bye.